Hi, I am Jumarie and Relente and welcome to the magical world of number theory analysis. Today, I will be giving you your second dose of our daily math medicine. I know that you have already mastered the basic terminologies in number theory. Today, I will discuss proofs. What is proof? A proof is a logical argument that tries to show that a statement is true. In math and computer science, a proof has to be well thought out and tested before being accepted. Mathematical proofs are often written in a formal style, but that is not required. Proofs can come in many different forms, but mathematicians write proofs often strive for conciseness and clarity. Now, there are types of proofs. First is direct proof or proof by construction. Second, indirect proof or proof by contradiction. And the last one, proof by induction or simply called mathematical induction. Many theorems state that a specific type or occurrence of an object exists. One method of proving the existence of such an object is to prove that P implies Q. In other words, we will demonstrate how we build that object to show that it can exist. A proof by construction or direct proof is just that we want to prove something by showing how it can come to be. Now, there are only two steps to a direct proof. First, assume that P is true. Second, use P to show that Q must be true. Say for example, if A and B are consecutive integers, the sum of A plus B must be an odd number. Following the steps we laid out before, we first assume that our theorem is true. We then can say that since A and B are consecutive integers, B is equal to A plus 1. In that case, A plus B can be written as A plus 1 or 2A plus 1. Therefore, we can say that A plus B equals 2K plus 1. We know that any number multiplied by an even number must be even. We also know that if we add 1 to any even number, it becomes odd. Given this, we can say that A plus B equals 2K plus 1. By definition, this only shows that A plus B is odd. Therefore, our theorem has been proven true. Next type of proof is proof by contradiction. A common form of proving a theorem is assuming the theorem is false, and then show that the assumption is false itself, and is therefore a contradiction. Say for example, if n squared is even, then n is even. Let's assume that n squared is even but n is odd. We're assuming that the theorem is false. By definition, let n equals 2k plus 1. By simplifying it, n squared equals 2k plus 1 quantity squared. That will be 4k squared plus 4k plus 1. And 2 times 2k squared plus 2k plus 1. And we will let m equals 2k squared plus 2k. And n squared equals 2m plus 1. Using the definition for odd numbers that we mentioned before, we must say that n squared is odd. In our assumption, we declared n squared to be even. Therefore, our theorem is true. The third and the last type of proof is proof by induction, or simply called mathematical induction. A proof by induction is just like an ordinary proof in which every step must be justified. It employs a clean trick which allows you to prove a statement about an arbitrary number n by first proving it is true when n equals 1, and then assuming it is true for n equals k, and showing it is true for n equals k plus 1. Example, 1 plus 3 plus 5 plus 2n minus 1 equals n squared. By following the steps of mathematical induction, let us show that it is true for n equals 1. So, substitute 1 to n. So, 1 equals 1 squared and 1 equals 1. Therefore, it is true for n equals 1. Next, assume it is true for n equals k. So, substitute k to n. Then it is true for n equals k. Substituting k plus 1 to n, we will have a new equation. 1 plus 3 plus 5 up to 2k minus 1 plus 2 times k plus 1 minus 1 equals k plus 1 squared. To prove, we have to show that 2 plus 2 times k plus 1 minus 1 equals k plus 1 squared. Solving it, k squared plus 2k plus 2 minus 1 equals k squared plus 2k plus 1. And k squared plus 2k plus 1 equals k squared plus 2k plus 1. True. Therefore, 1 plus 3 plus 5 plus up to 2 times k plus 1 minus 1 equals k plus 1 squared is true. Thank you for listening. That's the end of my discussion about proofs. Goodbye for now. See you around.